Today we're going to be talking about physically based rendering. So what is physically based rendering? It's a way of describing how to see something realistic within 3D graphics. So for example, Disney and Pixar created this standard, and it's used in Blender and Maya and 3D Studio Max, but it's also used within game engines. In this example, we're just having a look at Blender here, and within this Blender you can see here I have a wall, and on this wall I've got a high definition image. In fact, there are a few images that make up this image that you can see here, and you can see the ground. As part of this ground, I've set it on here. This is without lights. This is simulated lighting, so I didn't have to put my lights around my scene. And this simulated lighting, as you can see as I scroll or as I move around, you can see there's some shine off the floor, and it changes how the light is bouncing off the floor based off a few different things. Down here, this describes the workflow of how physically based rendering works. It's slightly different in Unreal and Unity itself, the game engines, and I'm sure it's different in Maya, etc. But you can do some pretty complex things. So you can describe how a image works. So in this scenario, we have the output down here. The material output consists of a couple of things. This is this material output. This is post-processing, taking the contents of whatever's in the surface, and also the displacement, and this creates a image on the fly consisting of a few different things. So let's have a look what we've got. You might be familiar with, if for 3D graphics we have base color, and the base color is in this case an 8K texture, and what I've tried to do is create something very generic that I can reuse and just tweak values along the way. So in this case I have a base color, and I haven't created any of these images myself. I've just downloaded samples. That's beyond my ability at the moment. I just want to use things. We also have normals, which is say which way the faces are pointing and how it reflects light. We have ambient occlusion. This is how we want our texture generally lit. We have roughness. So items can be smooth, which could generally bounce back a lot of light, and you can see a very high Fresnel or specular type approach. Or you can have a rough look, and this rough look can make it look which I'll show you in a minute anyway. It's better to show than it is to explain. Then we have metallic, so things can sometimes be rough and metallic, and this changes how the light is bounced back. Metallic behaves slightly differently. And then we have displacing the images, so some materials bounce off light in different ways. So where we start from is sometimes we have a texture, and we talk about UV mapping of where the U and V goes from 0 to 1 on a particular texture, on where it's mapped on X and Y, sorry. And on here we have some kind of post-processing on how we handle those images, how we have X, Y or Z location. So if I drag some of these, you'll see how on the background here, for this particular, anyone that's using this particular texture, you can see it's all moving of where it starts from. So minus value means opposite, and if I change this as the opposite, you can see it slowly flipping round. Or we may choose to rotate it or stretch it. So we can have them in different angles, and this had to be built up separately so that I have full control. And then finally we have an idea of scale. So sometimes, or most commonly, you'll have to set the repeat to mount on a particular image. And all these mapping, they all map to, for example, the image. For example, we don't want this scaled 20 times and then a normal scaled only once, because then it would look very strange. Normally what you have to do is everything comes from a vector and all scaled together. And in normals, depending if you're doing DirectX or OpenGL, this would either be pointing from the top left to bottom right or from the bottom left to bottom right. And then on the ambient occlusion, we have a mixture of both the normal and ambient occlusion. And the idea behind this is when we mix these two types of colors, we can get a different experience. At the moment, you can see it creates some kind of effect. But what you'll notice is on the ambient occlusion, I have no values at all. So it doesn't really do anything. It's just a good placeholder for me so I can reuse this workflow somewhere else. And then we could talk about normal map strength, so how much it reflects light, and obviously we don't want to have a huge value, and normally we'd just want to leave it as a default. And the roughness, we could decide how we want this to interact. You can see that it bounces lights off in a much different way depending on how the gamma is changed. So we can make it very funky looking. And then metallic, again, I've not used that value because this isn't metal at all. We don't want it to behave or look like metal. And then finally we've got rocks. So when we're talking about PBR, we are not, for any of these other textures, we are not, we're setting all the color space to non-color, except for the color itself, the texture map itself that does have the colors. The rest of these are all black and white images as such. And what these things do, these all filled into the principal shader. So Unreal and Unity and Blender, they have various different principal shaders for different purposes. In this one, this is the standard shader as such that we'd use, and in each one of these inputs is the output of these various nodes. As you can see, adjusting some of these values that are not plugged into a node, we can see, play around with. And then from here we have the output of the shader going to the material output, and also the displacement map. So there's a couple of different things you could do on the displacement map. Sometimes normals are good and sometimes height is good. As you can see, displacement is talking about, it's pretty much a height map. So that's pretty much it, and I hope this has been interesting, and let me know if it was or not.